variance of the first process is constant. It does not change in time. Okay? The variance of the first process is constant. It does not change in time. Sure? In a sense, yes. Right? In a sense, yes. The variance is constant.
But we assume that.
Yeah, because we assume it to be like that. Because we said that each year will be by some point and there is some environmental disturbance which is the same kind of a structure. Right? The variance of the environmental structure will change and so we have homogeneous. The variance of HT does not change. What do you think of this? So you can write YT as alpha phi, right? So alpha t really, you can write YT as, if I kept on doing this J periods, then this becomes alpha j, right? Plus E1 plus E2 up to Ej, right? Up to say, sorry. So basically I've got J periods back. So I write it as E1 plus E2 up to Et. There are J such E's. Right? I've done this J periods back, no? Right? So or in general, because I'm doing it T periods instead of J, think of T. So this will fit better. Alpha T plus E1 plus E2 plus Et.
And YT minus A equals YT minus A.
We'll assume that the initial value is 0 for simplicity. So we'll assume that YT minus J is 0. It won't change our analysis much, right? Because if you put that, that's right, alpha T plus Y0, that's the original Y, plus E1 plus E2 plus Et, right? Instead of J, I am using T now. You want T period back, so T minus T, Y0 is the original value of Y. So we know that expectation YT expectation YT is alpha T plus Y0 because you have the constant or the expectation E is 0. What is the variance of Y? Can somebody tell me what the variance of YT? You're right, but not perfect. Yeah? Sure? Right? Which will be what, friends? Expectation will be what? YT minus alpha T plus 0. So what do you get? What will you get? Yeah? What will you get? Say something, it's so simple. This is YT, this is expectation YT. This minus this is what? This is equal to expectation of E1, E2 plus E3, EP square. Right? What will this be? E1 plus E2. So what is the expectation of E1 plus E2 square? Expectation of E1 square plus expectation of E2 square plus 2 covariance expectation E1, E2. Right? Now E1 and E2 are all independent. So what is the expectation of E1 plus E2 plus E3 plus E4 plus E5 and Et square? 260. Why is it 0? It's a square, no? Yeah, covariance E1, E2, E3, all these are independent. So none of them have any covariance in anyone. T into sigma square. Because it will expectation E1 plus E2 plus E3 plus E4 plus E5 plus Et square will be expectation E1 square plus expectation E2 square plus expectation E3 square plus expectation E4 square and so on. Each of these expectation ES square is a sigma square. So this will be P sigma square, right? Sure? Now is this independent of T or does it depend upon T? Depends upon. So even when these two look similar, that is though their means were changing in time, there is another difference, there is a difference between them. In the first model, even when the mean changes in time, the variance is not changing. In the second case, the variance of yt is changing in time. Right? The variance of yt is changing in time. Right? The variance of yt is changing in time. So the variance of yt keeps on changing. Right? What do you say of the last case? So here, variance of yt. So in this model, what do you think is the case here? What is the expectation yt? So what is the variance of yt here? Expectation of yt minus expectation yt the whole square, which is what? Which is expectation of sigma, yeah? Which is what? Which is equal to E1 E0 plus E1 so on, ad infinitum, right? Sure? Or it will be like this. Yeah? This will be like this. Sure? And the whole square. So what is this value equal to? What is variance of alpha x plus beta y? What is variance of alpha x plus beta y? Alpha square variance of x plus beta square variance of y is the covariance between x and y is 0. Variance of alpha x plus beta y is alpha square variance of x plus beta square variance of y. So what will this be? Who's saying 0 on the right? But you are looking at the expected et square, not e. There is a square there. Perfect. No, so it will be, this first part will be only sigma square. So the second part will be phi square sigma square. Whereas the next part will be phi square square sigma square. Plus the next part will be phi cube square sigma square e and so on. Right? Sure? So that quantity will be, can I, are we here? This is visible? No, very big. So what I'll write here as, So I can write that as variance of yt is sigma square e plus phi square sigma square e plus phi square square sigma square e plus phi square cube sigma square e. Phi cube square is the same as phi square cube. Phi cube square is the same as phi square plus phi square raised to 4 sigma square e and so on. Yeah? Now if I take sigma square e out common, what will this be equal to? Sigma square e 1 plus phi square plus phi square square plus phi square cube and so on. This is now a geometric series on phi square. Because phi is less than 1, phi square is also less than 1, so geometric series in phi square. So this quantity will then become equal to sigma square e upon 1 minus phi square. Because that term inside the bracket will converge to 1 upon 1 minus phi square. This is geometric, this is geometric progression. The limiting value geometric progression is that 1 upon 1 minus phi square. Right? So the point now is which is a function of time or which is not a function of time? Not a function of time. So now you see the mean here changes in time. The mean here changes in time. The mean here does not change in time. Okay? The variance here does not change in time. The variance here does not change in time. The variance here changes in time. Right? The variance here changes in time. Right? So the last thing that we will look at is covariance between yt and yt minus 1, yt and yt minus 2, etc. etc. So the question that you have to solve for me is, what is covariance ht minus 1? Can you tell me what is the covariance between ht and ht minus 1? What is the formula for covariance ht minus 1?
So ht minus h1
Expectation of ht minus expectation ht into ht minus 1 minus expectation ht minus 1. So what is expectation of, so first calculate ht minus 1. Calculate ht minus expectation ht. So you have to calculate expectation of ht minus expectation ht into ht minus 1 minus expectation ht minus 1. So what is ht minus expectation ht? If this is ht and this is expectation ht, what is the difference between the two? E. So ht minus expectation ht is E. What would be ht minus 1 minus expectation ht minus 1? Et minus 1. If expectation ht minus expectation ht is et, ht minus 1 minus expectation ht minus 1 is et minus 1. So what you are asking is, what is expectation et minus 1? When you are asking for covariance between ht and ht minus 1, you are in fact asking the question, what is the covariance between et and et minus 1? And what is that covariance? 0. That covariance is 0. So does that covariance depend upon time? If I look at covariance ht minus 2, what will the answer be? The same, 0. I look at covariance et minus 2. If I look at covariance ht minus 20, I look at covariance et minus 20. All of them will be 0. So I will write in general covariance ht minus k is 0. Right? Covariance. So does it depend upon time? It does not depend upon time. Right. Now here, if I ask you to find yt minus 1, what that be? That will be what this be? So that will be, this is yt minus expectation yt. That is, this would be expectation summation phi raised to j. J goes from 0 to infinity, nt minus j. Right? And because we are going one period back, everything will be pushed one period back. Right? So you will be starting with minus 1 to infinity. So j goes from minus 1 to infinity, right? Yeah, j minus 1. So everything will be pushed back by 1 p. Right? So what do you think that product will be? So for example, let us have in the first place E2, E3, E4, E5, E6 up to E infinity. The second sum will start from E1, E2, E3 and E infinity. The first sum will go from E1, E2, E3 up to E infinity. The second sum will go from E2, E3, E4, E infinity. So if you multiply them, what will you have? And all of them will have a phi, no? So if you multiply them, what will happen? All the covariance terms will disappear. So E1, E2, E3, E infinity, E2, E3, E4, E infinity. Each of them have coefficient phi. So both will have E2, both will have E3, both will have E4, and then there will be E2, E3, E4, etc. The expectations of all these E2, E3, E3, E4 terms will be 0. So you will be left with phi square, expectation E2 square, plus phi square, expectation E3 square, plus phi square, expectation E4 square, and so on and so forth. Right? Okay? So in the end, what will you get? Sigma square 1 upon 1 minus phi square. Will you get this? Yeah, do you see the sums? You get phi square, there will be phi square left, no? And the sigma square term will be there. Right? So it will be phi square sigma square plus phi square sigma square plus phi square sigma square, so on, right? I see this will be like this. Let me give you a simple example. Okay. I have ET plus phi, ET minus 1 plus phi square, ET minus 2. Okay. I have to multiply that with ET minus 1 plus phi et plus phi square et minus 1 plus phi q et minus 2, right? Everything is pushed by 1 p. Sure? So if you do this multiplication, what will you get? If you first multiply et with all these terms, there will be no common term because there is no et here. So all the expectations will be 0. If you multiply phi et minus 2, what will you get? Phi et minus 2 into phi cube et minus 2. So you will get phi raised to 4 et minus 2 plus if you multiply, I am going with phi et minus 1, no? So first let me multiply throughout by phi et minus 1. If you multiply phi et minus 1, I will get phi et minus 1, phi square et minus 1. So I will get phi cube et minus 1 here. Sure? Plus if I multiply throughout by et minus 2, phi square et minus 2, what will I get? Phi raised to 4 et minus 2. Sure? It's easy, no? अरे इसको मल्टीप्लाई करो ना, phi raised to 3 et minus 2, phi square et minus 2, go phi square cube et minus 2. So basically, so it will be phi raised to 5 et minus 2. Sure? Phi raised to 3 et minus 2 and so on. Sure? And then I can keep on going like this. If there are more terms, then I can keep on going like this. Right? So look at what's happening here. If I take phi out common, and this will be of course squares. These are of course squares, right? Everyone is getting this simple multiplication. Remember, this has to be multiplied with all terms here. This has to be multiplied with all terms here. This has to be multiplied in terms where the time index is different will drop out because all those are uncorrelated values. Sure? Right? See, 80 plus phi 80 minus 1 plus phi square 80 minus 2 plus phi cube 80 minus 3 and this term is 80 minus 1 plus phi 80 because everything has gone by one period, no matter. Everything has gone by one period. This is phi square 80 minus 1 plus phi cube 80 minus 2. Right? Is this clear? So this is going to be, so if I solve this, if I take phi out common, then I got phi square sigma square e plus phi raised to 4 sigma square e and so on. Right? And if I have more terms, then those will be phi square sigma square e plus phi raised to 4 sigma square e plus phi raised to 6 sigma square e and so on and so forth. Right? So this will then I will be able to write this as phi into sigma square e and there will be sigma square e term as well, right? Because there will be an et term. There will be an et term, no? E square होगा ना? Because et को मैं सबसे multiply करूँगा तो e square तो आ जाएगा एक, ना? So sigma square e, I take sigma square e out common, then I get phi square square and so on. So this will become phi sigma square e upon 1 minus phi square. This will become phi sigma square e upon 1 minus phi square. That will become phi sigma square e upon 1 minus phi square. So the variance here will be covariance yt minus 1 will be see, it will be like this. Okay, it will be like this. Can I turn this around? See, it will be like this. So I have yt. so ad infinitum, right? So what will be yt minus 1? Yeah? What will be et? What will become et? Et minus 1. And so on. Right? So, this is what I am looking for. I want the covariance, no, between yt and yt minus 1. So it is expect yt minus expectation yt into yt minus 1 minus expectation yt minus 1. Expectation yt is this, expectation yt minus 1 is this. They are both the same. Right? So this would be expectation of et this term into so et minus 1 phi et phi square phi cube and so on, right? Now if I multiply these terms, what will I get? So et minus 1, et phi, et minus 2, et phi square, et minus 3 and all that, expect all those terms will be 0. Right? If I do with phi et minus 1, what will I get? Phi square et minus 2 will I get. Phi square et minus 2 square, that's the only term which will remain. Right? If I multiply with phi et minus 2, I will get the only term which will remain is phi square. Sigma square is the only term which will remain. Right? Plus, now, if I multiply with phi square, sorry. So if I multiply with et minus 1, yeah, so I get phi sigma square e, right? Because phi et minus 1 into et minus 1 is phi et minus 1 square, expected value is sigma square e. Right? Phi sigma square e. Plus what will be the next term? If I multiply with et minus 2, what will I get? Phi square et minus 2. That will be phi square sigma square e, right? Plus, now when I multiply with phi 3 et minus 3, what will I get? See phi cube et sigma square e. Phi cube sigma square e, right? Because